Hello everyone. Today we are going to be covering lesson 5.14, the triangle midsegment theorem. The notes I'm covering are available on OMHS, and a filled-in key will also be available. At the conclusion of this video, please don't forget to take your attendance quiz and do the lesson check. That is how you get credit for watching this video. All right, so the triangle midsegment is a segment that connects the two midpoints of two sides of a triangle. Remember, a midpoint is the point in the middle. So D is the midpoint of AB, and I know it's the midpoint because the two pieces on either side are congruent. AD and BD are congruent. E is the midpoint of BC because the two segments on either side of it are also congruent. So BE and AC are congruent, making E the midpoint. So in this triangle, the midsegment is DE. If a segment joins the midpoints of two sides of a triangle, so in other words, if it's a midsegment, then that segment is parallel to the third side and half as long. So in this diagram, DE is parallel to AC. And it is half as long as AC. So I can say that DE is half AC. If you don't like that fraction, you could multiply both sides by 2 and say 2 times the length of DE equals AC, and that would also be a correct formula for this picture. So in my example here, I have triangle QRS, and then I have midsegments XY, XW, and WY. And I know they're midsegments because each of these points is a midpoint of a side. So to identify the pair of parallel sides, it might be helpful if you used a highlighter. You're welcome to do that. I see that QR is going to be parallel to WY. I can see that QS will be parallel to XY. And we could say that XW will be parallel to RS. So we'll just write that in symbols over here. QR parallel to WY. QS parallel to XY. And RS parallel to XW. Wonderful. Now, in this example, it says that L, M, and N are midpoints of the sides. So as soon as I know that this is a midpoint of PQ, I know that PL and LQ are congruent. M is a midpoint of QR, so QM and RM are congruent. And N is a midpoint of PR, so PN and RN are congruent. It says that PR equals 46. So from here to here is 46. Okay, well now I can figure out the length of PN and RN. They're the same. So if I take 46 divided by 2, PN will have to be 23 and NR will be 23. It says that PQ is 40. So now I can find the length of PL and QL. Take 40 divided by 2, that'll give you each of those pieces. And the last part says LN is 17. So here's 17. Okay. That will help me determine what the length of QR is. Okay. The length of the midsegment is half of the side is parallel to. So 17 is half of what number? Or in other words, 17 times 2. Well, 17 times 2 is 34. So the length of QR is 34. And QM will have to be 17, and MR will have to be 17. I can figure out the length of MN. MN is parallel to QR, and so MN will be half of QR. I'm sorry, P. MN will be half of QP. So if QP is 40, half of that is 20. LM is parallel to PR. So LM will be half of 46, or 23. And now that I have all my numbers, I can just fill in the blanks. LM is 23. MN is 20. QR, that's 34, that's that whole side. And MR is 17. So the midpoint, the mid segment is half of the side that it's parallel to. Sometimes we'll see examples where we can't just divide by 2 or multiply by 2, but we'll have to use some algebra to solve. Looking at this picture, I know that this segment here with marked 7x is a mid-segment. And I know that because the two pieces here are congruent, which means this point has to be in the middle. And these two pieces are congruent, so this point has to be in the middle. So 7x is a midpoint. All right, I'm sorry, a mid-segment. 7x is a mid-segment. The mid-segment is half of the length that it's parallel to. Or, hold on, so mid-segment is half of the side that it's parallel to. Or you could multiply both sides by 2 and say that 2 times the mid-segment is equal to the side that it's parallel to. Both are right. This equation just multiplies both sides here by 2. It gets rid of the 1/2 for you, and then just makes a 2 out here. You can use whichever one you want. Personally, I like to use this one because I don't have to deal with the fraction. So here the mid-segment is 7x. So I'm going to say 2 times the mid-segment equals the side that it's parallel to. And now we'll use algebra to solve. 2 times 7x is 14x. Let's add 18 to both sides. So now I have 14x plus 18 equals 17x. I'll subtract 14x from both sides and get 18 equals 3x. Divide both sides by 3. X equals 6. If you solved this differently algebraically, but you still got x equals 6, that is perfectly fine, and I'm sure you did it correctly. Okay, example 6. Very similar problem. The mid-segment in this case is 6x plus 31, and the side it's parallel to is 19x minus 36. So I can say 2 times the length of the mid-segment equals the side that it's parallel to. Distribute that 2. So 2 times 6x is 12x, and 2 times 31 is 62. And now we're solving for x. I'm going to subtract 12x from both sides. Add 36 to both sides. And divide both sides by 7. So the answer is 14. You can check your work on either one of these. What you can do is take your value of x and plug it back into the picture. So if I wanted to check over here, this would be 7 times 6. So this mid-segment would be 42. And this would be 17 times 6. Minus 18. And this is 84. Is this mid-segment half the side that's parallel to? Well, 42 is half of 84, so we must have done it correctly. Here, I'm going to do 6 times 14 plus 31. So this mid-segment's length is 115. 19 times 14 minus 36 is 230. Well, half of 230 is 115, so we must have done that one correctly also. So that's a good way to check. If you end up getting an answer where your midsegment is longer than the parallel side, you probably set your equation up incorrectly, and so you should just be careful of that. The midsegment is half of the side is parallel to, not the other way around. Okay. In number 9, it says that MN, NO, and MO are midsegments. So as soon as it says that, I can confidently know that I've got some congruent pieces going on. Find the perimeter. Perimeter is the length around the outside. So we're going to find the length of all these outside pieces and add them together for the perimeter. Okay, let's start with the numbers that I see. Okay, so I see that this is 49. MN is 49. 49 times 2 will give me the length of JL. So JL is 98, which means that JO is 49 and OL is 49. I see that ON is 42. So that means that JK will be twice that at 84. So JM would be 42 and MK would be 42. Now over here I see that 13x is the length of KL and MO is 6x minus 1. So we're going to say that that midsegment, 2 of them, is equal to the side that it's parallel to. Distribute the 2. Subtract 12x from both sides. And let's add a 10 to both sides. So now x equals 8. So now I can find the length of MO. 6 times 8 minus 1. So MO is 47. And just to double check, 13 times 8 minus 10, 94. So now to find the perimeter of JKL, that's the big triangle, and we're going to add these outside pieces together. 84, 94, and 98. So the perimeter of JKL is 276. Okay. Let's look at number 10. Number 10, we want to find the measure of each missing angle. I see a couple triangles going on here. I see the small triangle down here that has angle 2, 3, and 4. And then I have a big triangle out here that has angles 1, 3, and 59. That might come in handy. Remembering that a midsegment is parallel to a side tells me that this midsegment, and I know it's a midsegment because it's connecting my midpoints here, it's going to be parallel to this side. And so we can use what we know about parallel lines, corresponding angles, consecutive interior angles, and so forth. Okay. So if I'm looking at just the red lines and this bottom line, well, I know this is 59, and if these are parallel, then the corresponding angles are congruent. So angle 4 has to be 59 degrees because it's corresponding to 59. What else can I see here? I see some linear pairs going on. Remember that two angles that make a line add up to 180. So if I do 180 minus 127, that will tell me angle 2. So angle 2 is 53 degrees. Because they're a linear pair. We know that angle 4 is 59. Well, I can find angle 5 because 4 and 5 are a linear pair. So angle 5 plus 59 has to equal 180. So angle 5 has to equal 121. Because if you subtract 59 from both sides, you get 121. Now let's look at what we have here. Angle 2 is 53 degrees. Here I've got a small triangle. In that triangle, I know that I have a 53-degree angle, a 59-degree angle, and angle 3. And we learned that the sum of the angles in a triangle is always 180. So we can add these together and then subtract from 180. So angle 3 is 68 degrees. Now I just need angle 1. We'll look at the big triangle now. Okay, I've got this big triangle going on. I know this is 59. I don't know angle 1, but I know that angle 3 is 68 degrees. So now I can say, oh, well, the 3 angles in this triangle have to add to 180. Combine 59 and 68 and subtract that from 180. So the measure of angle 1 is 53 degrees. You could have also found that by looking at angle 2 and angle 1. They're corresponding angles, which means they have to be congruent. So if you thought about that slightly differently, that's okay, as long as we got the same answer. All right. In example 12 and 13, we are going to practice using mid-segments, but also the angle relationships that we learned with parallel lines. So let's look at example 12. Example 12, I have mid-segments, and I know it's a mid-segment because it's connecting the midpoints of these two sides. As soon as I know it's a mid-segment, that tells me that these two lines are parallel. So if I'm looking at this angle and this angle, I've got my parallel lines, my transversal, and in my picture, we're looking at this angle here and this angle here. What angle relationship do these two angles have? Are they same side interior, same side exterior, consecutive interior, alternate interior, alternate exterior, corresponding? I may have repeated those. But what is the relationship between those two angles? These angles are corresponding. And if you weren't sure about that, I highly recommend going back and reviewing the angle relationships with parallel lines. The corresponding angles theorem says that if the lines are parallel, then the corresponding angles are congruent. So I can say that 7x plus 4 equals 10x minus 11. And now we'll solve for x. X equals 5. Okay. Over here, number 13. I have a mid-segment connecting the midpoints of these opposite sides of my triangle, which will be parallel to this side. What will the angle relationship be between my given angles here? These angles are consecutive interior angles. You may also hear them referred to as same side interior angles. The consecutive interior angles theorem says that if the lines are parallel, then your consecutive interior angles are supplementary. So I can say that those given angles add to 180. That's what supplementary means. And now we'll just solve for x. 5x and 11x, 2 and negative 30. We're solving for x. So x equals 13. So that was mid-segments of a triangle. Please also make sure that you have completed the course content for mid-segments. It provides you with more practice problems. Don't forget to take the quiz on this section also. All right, the attendance word that you'll want to enter in the attendance quiz is midpoints with an S. A mid-segment has endpoints that are midpoints and is parallel to the third side. So your word for today is midpoints with an S. Capitalization does not matter. Spelling does. Please spell it correctly. Midpoints. If you have more questions about mid-segments of a triangle, please let me know. I'm happy to help. I'm happy to answer your questions. I hope you have a wonderful day.